gentlemen, may I have your attention, please? The show starts in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, go.
Okay, hello everyone. There's one view. Really? There's someone are watching? I thought there's no one. Okay. It looks like there's no one at all because because I oop. Hello Quang Tuấn à. I just live stream and it's quite late in Vietnam and I just post into the Discord channel to keep the link. Actually, that I don't share this link to other. And hello, Quang Tuấn. Would you like to join to solve problem with me? I think there's Discord. Is there any delay in the live stream? Hi Tuấn, would you like to join the Zoom and Discord to solve problem with me? Let me create a Zoom link. I'm not sure that we can use the camera in both live stream and Zoom link. Can we do that? No, thank you. Okay, so I will show the problem alone. Actually, that there's no one at all. I live stream alone, and it happy that you watch I live stream. If you have any questions, feel free to post into the YouTube comment. Today I'm gonna to show all the problem in the study plan. There's a lot. So how about continue to solve a problem on the binary structure? Okay. So okay, let's solve this problem. Find the distance value between two arrays given two integer array 1 and array 2 and integer d. Return the distance value between the two arrays. The distance value is defined as a number of elements array 1 that such that there is not any element array 2 where this one minus this one. So let's do the proof first. So we have the answer here. Okay, so we define the distance value, find distance value. Return the distance value between two arrays. Distance value is defined as a number of elements. This one such that there is no element. So that this one less or equal to the distance is so the distance is number of elements. On array 1, I suggest there is no element in array 2 such that The absolute difference here is less or equal to this. There is no element, so this one will not valid, something like that. So we need to iterate in the length of array 1, or so it's a1 in array 1. So for j for a2 in array 2, if 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 all of them are not valid, so it means that if this one minus this one absolute value here, if it's valid, then if it's not valid, then it's good. If all of them such that there is no one valid, so there is no one that have this condition, so it means all of them are valid or invalid. Okay, so count invalid. The problem is a bit hard to understand. If the count here is equal to all of them, then the rest plus 1. Okay, let's try brute force first. Okay, so we can understand the problem now with the brute force solution. So this brute force solution will take the time complexity will be m multiplied by n by will be 1, where m is length of array 1 and is length of array 2. Okay. This is the by research solution, by research problem. So we need to find by research way to optimize. So for each element in array A, how can we know that if all of them are valid or not, invalid or not? If all of them are invalid, let's apply a function for if all of them are invalid. If we by research, we will to by research. I think we need to sort the array, maybe sort array 2. So if we will take n log n here. Okay, and this one after sort we need to after sort, right? After sort, for example, it will be in order. After sort, it will in order. Then we have each element in array 1, like 4, 5, 8. So how can we know that all elements in this one are invalid? How can we by research? I think we need to by research 2 times. Let a1 equal to 4. Then we need to check if all element in array 2 where this one of them all element in this one will greater than this one. So this is for check if all elements in array 2 A or satisfy 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 big rule. I'm a bit sleepy. All of them, right? So how about we take the first element? The first element is dash d here equal to 2. The first element here is 1. So the difference between them will be 3, and 3 greater than this one is correct. For the 8, the difference is 4, correct? The 9 here, 9 difference is 5, correct? So it looks like the difference is also in order. So let's take 4 here. So the difference will be like 3, right? 3 and go to 4 and 5 and 6. Look like in order. So all of them are greater than D. So this one is good. A2 equal to 5. Then we have the list will be 4, right? 5 minus 1 by 4 become 4. This one, the difference is 3. The difference between 4 and the difference between this one and this one is 5. So it looks like it's a decrease. I think it decrease sometime and then it will increase because it's this is the absolute difference. So it means that when this one minus this one equal a positive. So a positive, and this one minus this one become a negative. But when we get the absolute, it become the positive. So when it this one is always increase, so it's once this one minus this one negative, this one minus other will negative as well. But the absolute difference will increase. Oh, I don't think this is an easy problem for my research. So I will dislike. Yes, that's right. Vietnam time is 3:30. Okay. This is not an easy question, you know. Okay. A2 equal to 5. Minus this one become a positive. Positive and negative and negative and negative. But this one always increasing. Either this one increase or decrease. For example, that we have the element 2 here. So if this one increase and we have the difference between them or the positive, then this one will down. If it's positive, then it's down. Yeah. So it's have the graph like it down someone and increasing, right? When it when it's the positive one and this is a negative one. When it's the positive one, this minus this one will be 4. If we have 2 here, so this one will minus 2 will become 3. Then it will down. It will down. And when it become negative, it will increase. When it become negative, it will increase here. So how can we binary search to check it all static file? This is the look like it's a decrease and then increase. How can we check that all element? We check that all element here after we have the this look value here. Okay. It will okay. What else can we have? Oops, look like I have a zoom here. What I zoom here? Oops, I need to enter zoom code. Okay, what else can we have here? We may have, for example, that we have this one. Okay, so we may have a very small element. For example, that we may have the A1 to become a very small element. For example, that 0, lowest number. So we have 0 here. 0 minus this 1 will become 1, 8, 9, 10. So it's a negative 1, but it always increase. So the negative here, but it's always increase. Then positive in this case. However, that when A1 is the largest number, for example, that's 20 something like that. So this one minus this one will always positive. Always positive. So this one increase, so it will down in case of positive. In case of negative, so it's always increase. So one of them may is 6. So how can we check that all elements are in this one are greater than this one? Can we like this one minus this one greater than D? So I think that if we check all of them greater, then we also check if exists element that such that this one, so this will be invalid. So this will be good. So for this formula, we can decompose it. This one for K1. For K2, it will be this one minus this one less than minus D. Am I correct? Yeah. So when we have the minus here, and we move the minus into this one, so if you change this one as well. So this is correct. Yeah. So we have 2 cases. So all we need to do that we need to check if this one greater than this one minus D. or this one less than this one plus b. So we can combine them together, right? This one less than this one, and this one less than. Then this means that K1 or K2. So this one will be greater than greater than this is not an easy one. How can we know it's a variation? This is not an easy one, you know. This I2 here, this one. So we need to know that H2 here is greater than this one, and this is the R. So it needs to greater than this one, and it's less than this one. So for this one, this one is mean that we are end them, right? We are end them. But this is the case. K1, this one, less than A1 minus B, and this one greater than this one minus B. Yeah, this called confused first time. Okay, so is this correct? Yeah, so minus B here. Okay. So all we need to do with that, we need to check if this one greater than this one. We need to check if O A2 is less than this one, or O A2 is greater than this one. We have this value. So we have the A2 here in order, right? A2 here. What is A2 here? A2 here. Okay. Array 2 here. So if O this one is less than this one. So for example that in the case 1 equal to 4, B equal to 2, then that value you equal to 2. How do we know that O element here A is less than this one? Less than 2. O element here is less than 2. It's incorrect. How about this case? No. Not all element here, so it's for each element this is less than this one, or this is greater than this one. This is the R. So we have the 2 here, and we have this one, a1 equal to 4, d equal to 2, then a1 plus d will equal to 6. Oh, so this one less than 2 is correct. This one greater than 6, correct. How about that we binary search find 6 here to check to find the index. Binary search to find the index which is greater than 6, and this one we binary search to find index where it's e less than 2. So if, for example, that this one we find this index e less than 2, so if this one is less than 2, then all the element in the left side will less than 2. So in this case we found 0. In this case we found it's the index 1. So it means that if they are close together, if they are consecutive index, then it's a good one. Wow, I researched 2 times here. Quite complex, huh? What do you think, Quang Tuấn? It's quite complex. Not easy, yeah. Okay, so so we have the idea. So now just implement it. Then binary search to find. So we have K2, for example, that we have the target 2. Target 2 here, I mean K2. So it means that we need A1 plus D. So we need to binary search. Let's move to close so the implementation here for easy to check. So binary search to find the index greater than this one. Yeah, this is actually the bisect to find the first index which is greater than a target. So we just do the bisect right on the array 2 with the target 2. Okay, and we have the I write for this one, find the first index which is less than. So if we do the bisect left, we need to find a target 1 will equal to A1 minus D, right? A1 minus D. So we need to find the last index which is less than this one. So for this one, we just find the first index, okay, where greater than this one. Then our answer will be, this is the first index where this one greater than this one, so the answer will be 3 minus 1. So we just do the left will be bisect left array 2 with the bracket 1, and we minus 1, yeah, because this is the first, right, which is greater than this one, so 3 minus 1 will be the last index, which is less than this one. Okay, so now we just check if I left equal to I right plus 1, then rest plus 1. I hope my idea will be correct. What do you think? It's not correct. Why? So I need to debug. Bring I right. For A1, I need to play bring I right and I left. Alright, 2 is already short, so I need to debug on this. Okay, so array 2 is already sort into 1, 8, 9, 10. So first of all, I will check A1 equal to 4. Then the bracket 2 will be bracket 2 will be 6. Bracket 1 will be 2, right? 4 minus 3 will be 2. Okay, so so I bisect 4 here to find the first, like this one. Index will be 1, correct? Index 1 here, correct? Okay. And then I need to find the first index. Oh, which is correct here? Oh, left plus 1. Yeah, look like the idea is correct. And yes. Yeah. What do you think, Quang Tuấn? My body shot, you know. I do a lot of analysis to come with this idea. This one, we don't need to implement for binary search if we know like upper bound and lower bound that I already did us before. You want me to explain it again? Okay, so let me explain you again. So the problem is that given array 1, array 2, and for each element in array 1, to check if all elements in array 2 are satisfied this condition or not. So to check if all elements in array 2 are satisfied this condition or not, I will this one, you have 2 cases. If all element in for each A1, check if all element in array 2 are satisfied this condition. Okay. So for this condition, we how to say we how to say we how to say chúng ta giải kênh thì tiếng Anh gọi là sao Tuấn? Quang Tuấn, giải kênh của nó, chúng ta sẽ giải kênh của nó nè. Giải kênh của nó tiếng Anh là sao Tuấn? Mình giải kênh của thằng này đi. Then we have two case, k1, this one greater than this one, of course. Then a2 will become a1 minus d. Okay. And we have a k2. It does we have a k2, so this is the basic math. So this one will less than this one because we have the minus here, and we move the minus to d here. To move the minus to d, we need to change the greater, the lesser to become the greater to become lesser. Okay. Then this one will move to the right, so it will be greater than this one plus d here. Okay. Okay, so so it means that this one k1, this one k2. So we need to check if all element in array 2 are satisfy k1 or satisfy k2. So for to satisfy k1, so it means that we need to find the list of elements which is less than this one. And to satisfy this condition, we need to find element which is greater than this one. So the idea is that we binary search for k1 to find the list of elements which is less than this one. So for example, that this is 2, right? So the list of element will less than this one will become this element. If this one less than this one, so it means that if we find the last element which is less than this one, then all element in the left will also less than this one, right? All element in the left, because this is the increase non-decrease array after we sort. And do the same with k2. We need to binary search to find the list of elements greater than this one. So after binary search, we find this from this element greater than this one. So it means that all element here will greater than this one. So we have the list of elements less than, we have the list of elements satisfy k1, we have the list of elements satisfy k2, then all elements in array 2 satisfy k1 or k2. So to find list of elements or satisfy k1, we have the index of the last index which is satisfy this condition, and we have the index of the first element to satisfy this condition. So if all the list, if all elements in array 2 are satisfied, so it means that we have the list of the left and the list of the right that satisfy. So it means that the index here plus 1 will equal to this index. That's why I have this condition. Then we plus 1. Do you understand what I mean? Hiểu không anh Tuấn? Này xóa lại rồi. Hiểu rồi, kiểu như nó left right nó liên tục không được đoạn. Đúng rồi, left right liên tục không được đoạn á. Kiểu left là satisfy và right nó cũng satisfy luôn. Left and right nó đều satisfy, nó không đứt đoạn. Nó đứt đoạn thì tất cả các element in array 2 thỏa mãn thì nó thỏa mãn. Đọc bài này cũng khó với giỡn nó ta. Cái này khó á, không giỡn nữa. Bài research là khó. Do cái này cái độ phức tạp này là độ phức tạp giải đi 10 nhân là được, 500 nhân 500 được. Nên nó để là dễ, chứ còn để giải bài này bài research là khó. Phải phân tích ra cái này rồi ra cái này nữa khó này. Phải biết sử dụng bài research nữa. Bài này là khó. Ok, đã giải được một bài khó. Mất bao lâu? 40 phút á. Khó thiệt chơi giỡn á. Thấy decline không? This is hard to think on very short solution. Khó, very short khó. Thì độ phức tạp bây giờ nó sẽ được giảm lại. Độ phức tạp là solution 2 này, nên nó sẽ được giảm lại là can, chứ còn là cái này là O M nhân cho log N cộng N log N. Đó. Thôi. Giờ mình sợp này. Ok. Space complexity vẫn là O1. Cách này là interview xback này, nhưng mà cách này phân tích nhiều quá. Interviewer chỉ có Google rồi mới cho Uber. Còn mấy kia nó giải thôi. Proof of a binary search. The same with us. The same with us. This is a proof of solution. Okay. So we already finished for our first binary search. Binary search. Quite hard. So let's continue with this one. Okay. Find the smallest letter greater than packet given a character array letter that is sorted in non-decreasing order and a character packet. Return the smallest character in array that is larger than packet. Note that the letter wrap around. For example, that if packet equal to this and letter this, the answer is A. Okay, letter here is sorted in non-decreasing order. Return the smallest character that is larger than packet. Okay. Okay. For example, we have this and the smallest character greater than packet will be C. For this one, smallest character greater than C will be F. Smallest character greater than D will be F here. Okay. So this is already sorted. Then by research, we should think about by research. So just find the smallest, right? So it's find the first character with test less than greater than packet. Find the first character greater than packet. This is actually the bisaccharide. Find the first character greater than packet. It is actually bisaccharide. Okay, let's do bisaccharide. Bisaccharide letter here with the packet. So we have the first greater than the packet. Then any case đồng hấp. The answer. For example, that we have the letter, right? Will be A, B, will be Z, something like that. And the packet is A. The first character greater than packet will not found. What should we return in this case? What the hell? There's no definition on that. So just return. This is, I think this is the bad description. Yeah. Return the smallest character greater than packet. How can tray greater than what we need to output in this case? I know this crash in case not found, but what should we output in this case? Stupid question. This is the case of not found. Then what should we return in this case? I just return anything. What? How can C greater than Z? What? What the fuck? What the fuck? What the fuck with this problem? Ủa sao bài này đề nó kỳ ta? Tìm cái kích tự nhỏ nhất trong array mà đã lớn hơn target. Mà trong cái trường hợp này C nó đâu có lớn hơn J đâu. Sao lại trẻ về C? Khó hiểu nha. Đọc cái discussion rồi. Đúng rồi. Này tôi đọc 5 lần và không hiểu. Nếu mà input tôi về thì cái ký tự nhỏ nhất mà lớn hơn y sẽ là z. In a return vì wrap around là sao? Không hiểu. Nếu mà input là vậy thì how can ký tự nhỏ nhất mà lớn hơn target kiểu là phải là f mới đúng cho ta. Yeah. Trong khi này thì yes đúng rồi. I wait a lot of time to understand question as well. It's easier to think a question if find a nearest neighbor to give the target. Letter also wrap also, so if you reach the end of array, go to the first one instead. Reach to the end of the list, go to the first one instead. For example, Stacy is greater than D. Is not right because D had right. There was more like latter wrap around a very confused. Not that letter wrap around. For example, if target is Z and this one, what what it mean by the letter wrap around? Letter wrap around sao? What do you mean by letter wrap around? Hard to understand. No. Ok, bỏ qua nó đi. Nói chung là cái này dùng bisectile thôi. Cái Z không có trong đoạn EB nó trở về E thì đó không hiểu. Có cách nào ta comment xong nó nổi lên không là sao? Comment mà nó nổi lên là sao? Không hiểu. Nó nổi lên màn hình hả? Ra là xoay vòng lại trên. Xoay vòng lại là chọn cái đầu tiên hả? Cái này nó đi. Ok, arrange con. Bài này dễ rồi. Bài này coi vị dễ. Mà giờ mình giải những bài tập mà áp dụng bisectile nhiều chứ ha. Bạn có n coins và you need to build một cái staircase with this coin. The staircase consists of k round where the round has exactly equals. The last row of the staircase may be incomplete given return number of complete rows. Cái này đọc round hay row ta? Round hay row ta? Row. Row. Return number of complete rows of the staircase that you build. Chắc cài cái blocking hay gì đấy để bữa nào nghiên cứu thử, nó cũng vui. Nó cũng vui để mấy bữa lần sau livestream mà sử dụng cái đó thôi. Ok, thì bài này là có Leetcode hỏi mình build được bao nhiêu rows thôi, bao nhiêu row complete row thôi. Thì cái row bắt đầu từ 1 cho tới đây. Ok, thì mình sẽ search số row. Mình search số row thôi. Mình search số row rồi xong mình check thử với số row này thì nó sẽ cần được nó cần bao nhiêu cái đồng coin. Mà nếu mình dư số coin nó thì hợp lý. Rồi mình tìm số khác thôi. Ok, hiểu ý tưởng nha. Ý tưởng là mình search cái row trong range từ, tại vì số coin nó có khi không coin không. Ok, coin nó từ 1 cho tới n đó. Rồi với mỗi row for each row search các row search number of row number of rows in range for each n row count rows. Okay, for each row you need to calculate number of coins that it needs. Okay, so if the number of coins greater than the number of coins, then it's good. It's good, then it's good, and then we increase. Else we decrease rows. Okay. So by research, let's right y let's mix it calculate required coin of this one. If we have enough, then have the rest here, view 0 rows. Okay, if we have enough, we update answer, and we need to increase it by set into the left. Otherwise, we decrease number of rows. So we have the comment here. If row number of rows increase, then number of coins required coins increase. For do the same with the decrease. If number of coins decrease, then number of required coins decrease, then can buy research. Okay, we can rest here. But the range here is this one. Yeah, we can accept with this one, but I think we can optimize a bit. We have the formula here. So this is also a good question. Let's add it into the line. It's also a quite interesting question. So if we have the number of round here, round here, okay. For one round, so it's 1 plus 2 plus dot 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 plus round. So it will become this one plus what minus minus this one. This is the basic formula, math formula. So return this one. N nhân n cộng 1 chia 2. Okay. Because we have this formula, so it means that this one multiplied by this one, so it's n square here and minus this one. So this one, but the range here is big, so we can decrease the range here. By we don't show this is quite long for other languages. So if n here equal to this one, if you do the n square here, so it will be overflow. So we can, from the formula, we can know that the right here will how can we calculate the right? So we have the number of coins less than this one, and for the node round here, when we add round here, will up to this one. So this one multiply to less than this one. So apply this one square less than this one. So it means that the range is less than SQL of this one. Really? Okay. So this is a big factor. Can we be log of? Really? By V1. Do you understand one thing? This is basic by research. Quite interesting. I have this function less than this one. Because maximum this goes, so this one will less than this one. This one. So from the formula, why this one multiply this one become this one, but SQL this one will become 65536. Okay. I think this is not easy. problem. I think this is easy. Okay. Given array A of positive integer sorted in strictly increasing order and integer k, return the kth positive integer that is missing from the array. Let's proof of first. In the interview, if we cannot come up with the optimal solution early, we can do the proof of first. Return the kth positive integer that is missing from array. So it means that the positive integer that is missing from the array. So it's the positive integer. It means that start from one. One is missing. For example, we have a graphic example. We mix one. We mix 5, 6, 8, 9, 10. So the case, the 5 will be 1, 2, 3, 4, 5, 9. Okay, I put 9. If we do the proof of, then because this is increasing order, return the case mixing. So we just y k greater than 0. Then need to count the number mixing. Start from 1. Next element, something like next element that we expect. We start from 1 and index 0. If we expect this one, but we mix this one, then the number of mixing will equal to we expect 1, but we mix 2. So it means that we mix this one minus this one. Why? Right. We expect 1, but it come out is have 2. So it's mix this one minus this one. At plus 1. There may be other case that the next element is is equal, then x5 just skip, x5 just skip. So is there any case that next element is greater than the current element? Cannot, right? Is there any case that because we start from 1, so it cannot have this case. So it cannot have this case. So in this case, we k minus by number mixing. And we update the next element that we expect will become the next element plus 1. In this case, next element will plus 1. Okay. and I will less than len array, and it will continue. Yeah, and then the next element here will be the first mixing element, the kth mixing element. Right? For example, that this, let's try run the test. So we have the next element here. We start from 1 and we mix 2. So this one less than this one, so it means that number of mix here we mix 1 is already fulfilled, so it's become 4. And then the next element here will become 3, and this match. Next element will become 4, and this match. The next element will be 5, but it's 7, so it's make 5, 6, so it's make 2. So make 2. So the number of mixing is 2. And then the next element will be 6. Will be 8. Next element will be 8, and this is 11, and this. So we need to find the minimum. From A we have 3, but this is -1. This one -3 become -1. And the next element here will be 11. Will become 12. Will become 12. So we need to know that it should be 9. So 7, 8, and 9. So if it's greater, if the so if it's greater, how about equal? If it's still half, then we check minus. How about if equal? For example, that we have the 9 here. We have the 9 here. Then it's equal to it should be 10. 10, then actually we mix 8 and 9. We need to output 9. So this one minus this one, if it equal, then the answer will be the next element first with the mixing. For example, this one minus this one will be 3. This cannot. So for example, that if this is 9, then it make 8. This one, if we make 3 like 8, 9, we make 8, 9. Yeah, so it will be 2. 2. Make 2, then we return the answer as well. Okay, so the next element will plus with the number of missing, I think. For example, that we have 8 here. We plus with 2 will be 10 minus 1. Hello?
Sorry, is there still stuff in the washing machine?
Yes.
I see it's
Yeah.
finished.
Yeah, it's finished.
Thank you.
Yeah. No problem. I will. Good. Okay. Thank you for reminding. Okay. It's quite complex. So it's fulfilled and it's good. Alright, return next element. This one no missing, right? Oops, why? So let's debug. Okay, for the first one, 1, right? So 1 will less than 2. So the number of missing will be 1. So minus 1. So this will become next element will be 2. Next element will be 4. Whoop. Whoop. This one must be plus after. Mix 2 plus number of mixing minus 1. The same with this one. Okay, so this is linear time. Let's think my research later after I hang up my clothes. Because when after the washing machine is done, my flat may ask me to take out of the clothes for her to use the washing machine. So I need to hang out my clothes. Otherwise, it will become not fresh or not how to say, I don't know, not messy, I think. It's almost done. Just to close left. To close left. One close left. Okay, it's done. So let's continue. Ooh, so why this logic is quite complex? Because this is increasing. Okay, so can we do it by research? Solution one, we take the time complexity will be O(n). By complexity will be O1. Solution 2, by research. How can we by research for it? Let's grab the example here. We by research what? We by research the missing number. How can we by research? By research what? By research the missing number. And by research what? By research 5. How do we know that 9 is correct? If we do the pre-calculate for the distance here, if you take the O(n) less than O(n), Facebook, Amazon, Microsoft, Google, TikTok, Adobe. By research what? Do you have any idea, Quang Tuấn? By research what here? Is there any hint? Okay, hint here. Keep track of how many positive numbers are missing as you scan the array. How can we know that if we do O(n), we do O of n? Keep track of how many positive numbers that are missing as you for example, that if we pick the array a equal to 7, for example, that if we add index like 0, 1, 2, 3 here, then from left to this one, we have the number of elements here will become 4, right? Number of elements will equal to do the mix minus with the left minus with, so it means that mix plus 1. So, number of elements are missing from this one. Number of elements here will be equal to like 4, right? Yeah. Index plus 1 will become the number of elements here. But this is 7 and this is 2. if this is 7, so it means that the number of expected elements will equal to, like we have 7 number here, right? I have 7 number here, but we have the number of element here, so the number of mixing will equal to, we have 4 number of mixing here, right? Equal to 3. So 3 from this one to this one we have 3 number of mixing, right? 1, 5, and 6. Correct, which is correct. We don't need to care about value, right? We don't need to care value. We need to care about index. So it have from 7 here we have 3 element mixing here, so we expect like 2 more, so we need to return, we can return 9 here. But how do we know that when to stop? If we have mix here equal to index 4 here, 0, 1, 2, 3, 4 here, then the number of elements will become 5, and the number of expect element will become 11, but and the number of mixing will equal to 6, which is greater than this one. From this one to this one we mix 6, which is 1, 5, 6, 8, 9, 10, which is 6 number mixing. Which is not correct, which is greater than this one, so we decrease the index. So the condition is that if it's greater, then we decrease the index. How about that it equal? For example, that it is 9, and we have the number of mixing will be 5, which is 1, 5, 6. From this one to this one we have the 5 number of mixing, right? 1, 5, 6, 7, 8. So it equal, we also decrease until it's less than, then we need to plus. Okay, so this is the right equal to length of array minus 1, y left equal to right, look equal to left plus right 2. If number of element will equal to mix plus 1, number count expected element equal to array of mix low number of mixing element will be equal to minus this one if number of missing is greater or equal to k, we need to decrease the index. We need to update we need to find the first, the last index which is less than k, I think. So we do the okay. So we do this on the line of array. So it's greater than this one where we need to decrease. We need to increase between two updates, right? We need to increase. After we to find the index, increase that's possible index. Okay, then we have the index here, and then we just like have the array of index we plus with we have this logic again. Number of mixing from, for example, that we have 7 here. The number of mixing will be 1, will be 7, will be 3, like 1, 5, 6. So we have number of mixing will be array of rate minus rate plus 1. So number of missing here. So we have k here minus number of mixing. Okay. I think there's some sk as well. Yeah, this is very short. This is very short. So if we take O plus N in time complexity, and by complexity will be O1. I think there's other sk as well. I research to find the last index which has array high less than this one. No, it's not number mixing. Let's apply function for count number of mixing of this index. In which we better split a function for it. Number of number of element will be I plus 1, and number is exactly this one. Number of mixing will be this one plus this one. Number of mixing is rest. And this one is number of mixing of mix. so we can reuse our function. It makes our code clean, more clean. So if we define this, so let's swap this, so it will make it more natural. If it's less than k, then yeah, it's good. How about that in the worst case? In the worst case, that if for example that it start from like 10, okay, equal to 3, something like that. So that the number of mixing here will be the mixing number will be 3, 1, 2, 3. So in this case, it doesn't found. In this case, it doesn't found any index which has with number of mixing is less than k. For example, if this one number of mixing will be 9 number of mixing, right? So it's cannot less than k. So the result here will be -1. So in this case, how can we add the okay? So let's handle the sk. If rest equal to -1, then array here cannot materialize. So it cannot found anything. So we just return the array, return the k. Yes, I think so. Yes, you know. Do you have any questions, Wang Tuấn? I think you're out already. It's quite a long session. Oops. Oh, yeah, it's still correct. My battery shot is powerful. So the idea is that we just count number of mixing. If we pick someone count number of mixing, and then need to find the last index, which is the number of mixing less than 1, and then we have this one. Otherwise, we cannot find. We return in this case, for example. For example, this case, return k. Okay. Oh, it's a hard question. Not the easy one, huh? Okay, thank you for watching. Bye bye.